This is Pam Smith. I'm the crops and production editor for Farm Journal magazine, and I'm here with Dr. Gary Stacey from the University of Missouri. We had a press conference where we talked about the soybean genome. And Dr. Stacey, we hear about the human genome, we hear about all this genome. What's it really mean, and what's it mean to farmers?
Well, what the soybean genome really does, what the analogy you can use is it gives you the parts list. But of course, it's very important to know the parts list, but it's not enough to only know the parts list. But the genome sequence is really given this parts list. Probably the first impact that the farming community will see is that we're developing more what we call molecular markers. You can think of these as kind of mileposts along a road. And so what those markers do allow us to know where we are on the genome. So when we try to recombine genes to make elite cultivars, we need to kind of know where we are on the genome to understand how we've recombined the genome to make these elite cultivars. And having these markers and really increasing it, just like the human hap map, we now have a soybean hap map. That I think is going to be the first impact that the farmers will see, an acceleration of the ability to use molecular breeding to bring cultivars to the farm.
And also, a lot of this is a result of farmer dollars from their checkoff money, is that right?
Absolutely. Really, I credit the USB, the United Soybean Board, with starting all of this. I haven't checked the dates on this, but I think roughly 7 or 8 years ago, they funded a project to do what we call EST sequencing. These are what express sequence tags. What that really means is we were sequencing individual genes, not the whole genome, but we were doing it in a very large way. So we were trying to get all the genes in the genome. And that really was the beginning, and those were USB dollars. The other thing which I felt was very, very important, I mentioned in the press conference, is it was USB-sponsored workshops that allowed us to bring the soybean community together, public, private, and also USDA scientists, and develop a cohesive community, which I think was very important when we went then to the Department of Energy Joint Genome Institute and tried to convince them that there was a community out there that really wanted this resource. And so I really credit USB for that. But all along, USB has funded a variety of projects that impacted the final production of the soybean genome sequence.
Okay. And you also mentioned something that I had taken note of was linkage drag.
Yeah. So what a lot of the agricultural companies are trying to do now in soybean and also in corn are what we call stacked traits. What that means is no longer enough just to have a plant that has high yield. You want a high yield, you want herbicide resistance. In soybean, you want SEN resistance, you probably want fungal resistance, and so on and so forth. Now you may probably want 2 forms of herbicide resistance because of the development of Roundup Ready resistant weeds. So that means you're going to put multiple genes in. Well, using classical breeding, you can think of genes as dots on a long string. So if I want to bring in a good dot, that good dot is maybe attached on that string to a bad dot. So how do I bring in the good dot and leave the bad dot alone? Well, I need a marker between the two where I can separate them. And having the genome sequence and developing these large number of markers now, the soybean hap map, should allow us to do that, to break some of this linkage drag. So I think that's going to be a very positive thing.
Excellent. Thank you for your help.
Yeah, thank you.